Hi everyone, so I thought I would put together some revision notes basically for differentiation. I've just summarised these into points really, so hopefully you find this useful. So the first thing we have is ultimately when we differentiate, we find the first derivative of a function, okay? And the first derivative can be used to find the gradient at any point on the curve, okay? We find this gradient by substituting in a given x value into the derivative, okay? So just a side note, if your gradient is 0, then your point is a stationary point and you can use the second derivative by differentiating again to find whether it is a minimum point, a maximum point, or a point of inflection. Okay, so point 4, we can find an x-coordinate when we are given a gradient, okay? We, of course, need to find the gradient, so if you don't already have it, you need to find the first derivative by differentiating. And then what you have to do is set this equal to the gradient given and solve, okay? This is where a GDC comes in useful, but most of the time, certainly on the standard level papers, it is also possible to solve using factorising and then, subsequently setting your brackets equal to 0, okay? Another thing that you may be asked to find is tangents to the curve. Now, the key piece of information to note here is that a tangent will have the same gradient as the point given on the curve. So, of course, this is what you need to use, and then you use the x-coordinate, your gradient found, and you substitute into your y equals mx plus c formula. Okay, this is a very similar process when finding a normal as well. The only thing to note here is that whatever the gradient is that you find on your curve, the gradient for your normal will of course be the negative reciprocal, okay? If that doesn't spring to the forefront of your mind quickly, then I would advise you just go back a bit, practice your y equals mx plus c topic, and finding perpendicular lines, tangents, etc. Okay, finally, I thought I would just take you through a couple of examples of how to actually differentiate. So, point 1, you need to bring the power down in front of the term and multiply. The second step is to subtract 1 off the original power. So, here in the first example, f of x is equal to 3x to the power of 4 plus 4x squared plus 2x. You can see the step-by-step process of first bringing down the power in front to multiply and then subtracting 1 off the power, okay? And then on to the second example. This literally just shows you, first of all, how to rearrange. So if you have a function written with your x to the power of something on the bottom, you simply need to first rewrite with a negative power, okay? Once you've done this, you can just follow the same steps as the first example.